8.2 is all about graphing quadratics still, so continuing on what we were doing yesterday, except we are now going to be graphing like exact points. Oh, hello. So remember yesterday we were doing sketches? Today we're actually going to have like legitimate coordinates to graph on our graphs here. The requirement is that we graph at least 5 points. For all of these problems, we will be graphing 5 points. It's not as much work as it sounds like. I'm going to show you a lot of shortcuts and freebies to help us get 5 points. So we're going to be okay. Are you ready for the first problem? We start off by determining the shape of this graph, which we did yesterday. So that's going to help us like guide the rest of what we're doing. So we're going to start by identifying A, which is -2, B, which is 4, and C, which is -1. You remember doing that yesterday? Then the A value, this first number here, -2, is what's going to determine all the shape of this graph. Is this graph opening up or down? This one is down because A is negative. If it opens down, here's a little sketch. Is that vertex a maximum or a minimum? And then what do we think? Is this graph going to be stretched, tall and skinny? Or is it going to be compressed, which is short and fat? Or is it going to be neither? Oh, what do we think? Not neither. Nope. It's stretched. Stretched is for any number for my A value that is greater than 1. Remember, we don't care about that sign. We don't care that it's a negative. We just care that it's a 2. So the 2 there is telling me that this is stretched. All right. So then, now that I know its shape, I'm going to keep that in mind as I continue working through this problem because that shape better match my final product. Then I'm going to start getting some points. The first point I can get is the y-intercept. Do we remember how we determine the y-intercept? It's 0, comma, whatever the c value is. So this c value here is -1. Chess. Oh, okay. So the next thing, once we get our y-intercept, that's going to help us in a second. The first thing I want to actually graph on my graph is the axis of symmetry. So we have to find the axis of symmetry first. Can somebody remind me what the formula for axis of symmetry is? I'm going to write it up at the top here. Perfect. -b over 2 times A. So I'm going to take a look at my equation. I want -4 is already positive, so that's going to become a -4 over 2 times A is -2. That simplifies to x equals -4 divided by 4 is 1. And that's the very first thing I'm going to graph on this coordinate plane. So let's go ahead and make our axis of symmetry right down there at 1. This is what we did yesterday. So everybody still feels good about this, right? Yeah. Okay. Then, yesterday, when we were just sketching, we found the vertex and we kind of just estimated the rest. Now, we're going to find the vertex and then find 4 more points. What we're going to do is we're going to do it in a table. And the most important thing that we have to get right every single time or else our table all falls apart is that the axis of symmetry, whatever we found, goes right in the middle every time. So this table is helping us find the x-coordinate or determine the x-coordinate, do a little bit of work, and then find the y-coordinate on this side. So I'm going to use my formula, like I did yesterday, to help me determine that vertex. So I'm going to take this original formula and plug in my axis of symmetry. So this is like -2 times 1 squared plus 4 times 1 minus 1. I'm going to simplify each piece. So this first part, 1 squared is 1. 1 times negative 2 is negative 2. 4 times 1 is 4. And then minus 1. So negative 2 plus 4 minus 1 is it's a positive 1, right? Positive 1. So there's the coordinate for my vertex. It is 1, 1. Maybe make yourself a note. That's your vertex right there. So because we graphed that axis of symmetry, when I plot my vertex, that vertex better end up on the axis of symmetry or you did something wrong. So 1, 1 is right here, and I'm good to go. I'm going to look at everything we've done so far. You see all this about the shape? How we know that this is going to face down and that vertex is a maximum? So if I'm looking at this graph as I'm going and plotting the rest of the points I'm about to find, I better not have anything that's up here, right? Every point that I plot from here on out should be below this vertex because we're facing downwards, right? And because that point's the maximum, so everything better be lower than that. Now, here's how we determine the rest of our points. I need 4 more. I'm going to pick 2 on either side of this axis of symmetry. So 2 that are bigger than 1, 2 and 3, and 2 that are smaller than 1, 0 and negative 1. I'm counting by ones. Your default should always be count by ones. Don't count by anything crazy. Don't pick random numbers. Count by ones. Okay? One of these values is going to be our first freebie. We don't always get this, but we do in this problem. Do you know what it is? The y-intercept. Anytime I get a 0 in the x column, that is my y-intercept. That y-intercept we already found. It's 0, negative 1. And then I'm kind of out of freebies for right now. So the way that we get the rest of our points is now I'm going to do the same exact thing I did for my vertex. I'm going to take my original equation and I'm going to plug those x values in. Let's start with number 1, and then I'm going to show you that we have a couple more freebies we can do. So this negative 1, I have negative 2 times negative 1. Look at how that goes in parentheses. That's important. Squared plus 4 times negative 1. And then minus 1. Negative 1 squared is positive 1. Positive 1 times negative 2 is negative 2. 4 times negative 1 is negative 4. Minus 1, that's a negative 7. Everybody good with that so far? Let's plot the points we have. So I have the y-intercepted 0, negative 1. And I just got another point at negative 1, negative 7, which is there. We're good up until this step? Now, what do you think I'm going to tell you the freebie is here to get my other 2 points nice and easy? I hear whispers of it.
That's what Reed said.
What are you talking about, Reed? What is this line right here? The axis of symmetry. And what does symmetry mean? Cody? It's the same on both sides. So guess what we get to do? We get to take these points and we're going to reflect them onto the other side of my graph. So I'm going to take this point here, that's my y-intercept. It is 1 spot away from my axis of symmetry. So I'm going to put it 1 spot away on the other side. And then I'm going to take my point that's down here. It's 2 spots away from my axis of symmetry. So 2 spots away on the other side is right here. So now let's look at these points that I just put on here. This one right here is 2, -1. So in this spot, I want you to be writing 2, -1. Hey. The other point that's on here is 3, -7. So right next to that 3, you want a -7. Do you notice something about your table now? There's a little bit of a pattern. Do we see it? So this is going to help us. This is if we did this correctly, if we mirrored them correctly, these guys should match, and these guys should match, and then we get a little bit of a freebie, right? Those are done. Let's finish this off by graphing my parabola. Should be a little bit curvy, hopefully. And then just double check one last time. Does it open down? Is the vertex a maximum? Does it look stretched, tall and skinny? Looks pretty good to me. Good? Let's do it again. Lots of things going on in letter B again. It does open upward. Why do you know that? Because A is positive. That means do I have a max or a min? Stretched, compressed, or neither? This one is stretched because my A value is 3. It's bigger than 1. What's the y-intercept? That comes from this C value right here. Axis of symmetry formula. We have to be careful with our axis of symmetry formula because if we get the wrong axis of symmetry, your whole problem is going to be wrong. So I got to be careful. I want -b. Do we see how B is already negative right here? So it's going to be a +6 because I have -6 over 2 times A, which is 3. So +6 over +6 is 1. This one just so happens to be the same axis of symmetry as the last time. So let's graph it. And then what am I going to do first in my table? Not 0, -1. 1 goes in the middle. My axis of symmetry goes in the middle. And then what do we call this point right here? Vertex. Okay. So then that vertex, we're going to find it by plugging it into my original equation. 3 times 1 squared minus 6 times 1 plus 1. 3 times 1 squared is just 3 minus 6 plus 1. It looks like it's going to be at -2. So 1, -2 right here. How do I determine the other points that I'm going to plug in? What points do we want to use here? Jaden. Okay, 0 is 1. Can you have the rest of them? And then Jaden said that this one is my y-intercept. So what's the y value here? Yep, 1. And then I like to make it easy for myself. 2 and 3 are usually bigger numbers. If I can deal with 0s and 1s all day, that's what I want to do. So I'm going to deal with this -1 here. And I'm going to plug this value in. -1 squared minus 6 times -1 plus 1. I'm going to take it piece by piece. -1 squared is 1. 1 times 3 is 3. -6 times -1 is a +6 plus 1. That looks like 10 to me. We're going to plot what we have. 0, 1. Oh, sorry, that's 0, -1. I want 0, 1. And then I want -1, 10. There we go. Then what? Then we're going to flip them. So I'm going to take my point on the y-intercept. I'm going to flip it over. That is at 2, 1. And then I'm going to take this point, flip it over. That is at 3, 10. Do my things match up? Are they symmetrical? Looks like it. So I'm going to draw my parabola in best I can. Arrows on the ends. And finally, I'm going to make sure it matches up. It opens up. I got a minimum. Looks stretched. Good to go. Questions on this? Yes.
So we don't even have to do like the bottom part of the...
As long as you are checking that it's symmetrical, it's good. But this also means if you're not doing the work here, then you're not actually like checking yourself. So like doing the work is a good way to make sure, hey, if I got the wrong number, something is wrong here. So you better be confident that you got the right axis of symmetry and the vertex, and that when you plot your graph, it actually matches up to these things. Because if you plot it and it looks funky, don't just move on. It looks funky because you did something wrong. Does that make sense? Okay? So it's not just like, oh, it looks weird, but that's probably fine. It should look like this. Okay, let's move on to the back. I think we should do both of these. We'll see how the first one goes, and then we'll see. All right, letter C. My A value is 1/2. My B value is -4. My C value is 3. So help me out here. Does this open up or down? Max or min? Stretched, compressed, or neither? Compressed because we are less than 1, between 0 and 1, right? Those are not always necessarily just fractions, because we could have fractions bigger than 1, but it is a fraction smaller than 1, so that's compressed. Y-intercept is? Beautiful. Axis of symmetry. We got to make sure that we get this right, because this is going to determine whether our whole problem goes well or if it all goes crazy. So I'm going to do x equals negative. Hey, look, my b is already negative. So that's a -4 over 2 times 1/2. -4 is +4. 2 times 1/2 is 1. So that's x equals 4. So let's get our axis of symmetry at 4. There it is. Then what goes in the middle? That's my vertex. Oops, I want that in orange. I'm going to plug it in. Let's find my vertex real fast. What's my original? 1/2 times 4 squared minus 4 times 4 plus 3. Okay, piece by piece here. 4 squared is 16. 1/2 of 16 is 8. -4 times 4 is -16. And then plus 3. So 8 minus 16 is -8. -8 plus 3, -5. That's my vertex. Right here. Huh? So we've got our vertex. Then I want us to think about what points we're going to pick, because I'm going to shake things up on you a little bit. Take a look at this. If we were to pick the points counting by 1, we would get the next number after 4 would be 5, right? Okay, so let's square that. 5 squared is 25. Half of 25, 12.5. Is there a single one of you in here that wants to graph decimal places? I don't think so. I don't want to do it either. So instead, here's a little special rule. If my A value is a fraction, so like 1/2, we want to count not by ones, but by the denominator. So in this case, we're going to count by 2s, and that'll help prevent me from getting any weird decimals. If it was like 1/3, we would count by 3s, right? So it's counting by that bottom number. So instead of 4, 5, 6, we're going to do 4, 6, 8, and then 2 and 0. Hey, look at that. We got a y-intercept, which we wouldn't have gotten if I hadn't counted by 2s. So that's like just free for me, right? So let's use that y-intercept. What did I say my y-intercept was? 3? Load 3. And then I have to plug in this 2. I can't avoid it, but hopefully that's the last one I got to plug in. 1/2 times 2 squared minus 4 times 2 plus 3. 2 squared is 4. Half of 4 is 2. Oh my goodness. Minus 8 plus 3. So that's 5 minus 8, so -3 here. We're going to plot them. Be careful here, because we're not counting by 1s anymore, we're counting by 2s. So I should have a point at 2, -3, which is this one right here. And I have another point at 0, 3, which is over here. I'm going to reflect them. This first point is 2 away from my axis of symmetry. So it looks like I want, what is that, 6, -3. And then this other one is 4 away from my axis of symmetry, so that looks like 8, +3. I'm checking. Everything looks like it's matching up. I've got matching there, matching there. Does my graph go upwards? Do I have a minimum? Does it look compressed? Does it look a little bit wider than the ones we've done so far? Hopefully it does, right? Looks a little bit wider. Okay, any questions on that? I won't do this whole third problem, but there are a couple things that I want to point out on this third problem. Can you guys tell me what's weird about letter D here? There's no C value. So what do I put in place if there is no C value right here? The y-intercept is 0, 0. Okay. What else do I need to point out? Oh, okay. So let's assume I find my axis of symmetry, which we can just do our axis of symmetry real quickly. It's -2 over 2 times 1/2. So that's a -2. So if I put my -2 in here, what other points do we want to pick for this graph in particular? Okay, what else? Perfect. So we know we're counting by 2s because we have a fraction up here in our A value. So I'm counting by that denominator. That's going to prevent me from having any weird numbers. Are we okay if I don't do the rest of this one? Okay, fantastic.